Hello, everyone. Time for combustion reactions. These are the ones that produce the crazy amount of oxygens. Well, that's how I always think about them. So for right now, we're only doing carbon combustions. That's what we're focusing on this unit. And so basically, a hydrocarbon is what its name is. It's something that has hydrogen and carbons. And just remember, those will be given to you. But basically, the general setup for this is a hydrocarbon plus oxygen, because as we all know, O2 brings off. And as we all know, for fire to work, we've all seen the fire triangle probably. You need a fuel source, you need oxygen, and I don't remember the third thing at this moment. But so that's why oxygen's there. And then this is going to produce CO2 and water. And that's it. And the setup for these are really simple. We're going to assume that these combust all the way, because if they don't, you could have carbon monoxide, but that gets into a whole nother can of worms. So we're just going to go with this. So an example would just be if that's a methane burns in air, methane burns completely. Anything if you see burns, combust. So methane is CH4. And then we're going to have our oxygen, which is going to lead to and carbon dioxide and water. And you can technically put the states of matter, but I don't feel like doing that. So, as always, we need to balance this out. So we have 1, 1, 2. We have 4 over here, but we only have 2 here. So make that 2. So now we have 2 plus 2 is 4, so we just make that 2. So that one was really simple. Let's do a more complicated one, because that was way too simple. So complete combustion of butane, I think is what I wrote. So butane is apparently C4H10, and then of course the same oxygen and carbon dioxide plus water, which would probably be water vapor. I mean, it's so hot. So we have 4 here, so we need 4 here. So we stick the 4 there. So, and we need 10 here, so we put 5 here. So now on this side we have 8 oxygen plus 5, which gives us 13. Well, we have a problem, because you can't have 6.5 oxygen. You can't split an atom. You can split an atom in half, but that's, you can't have half an atom just chilling. So we need to fix that, and the best way to fix it is to double everything. And this is where those crazy huge numbers come from, because we're going to have 2. So now we're going to have 8 here, and then we're going to have 10 here, but now we have 16 plus 10, which gives us 26, and we have 2 oxygens over here, so half of that is going to be 13. A little pattern I've noticed, if say that number is something huge and you don't want to half it, is whatever you originally got when you added it before doubling it normally becomes your coefficient over here. Now, I don't know if that's an actual rule, so don't quote that. I would double check your math. But, if you're like doing homework or something and you want to rush through it, that might be helpful. And so, again, that's it for combustion reactions. There's not a lot that goes into them. Yeah, and of course, just remember, these are not the only type of combustion reactions. These are just hydrocarbon ones. there's other combustion reactions that convert into oxides, and which is like ash, because we can burn paper, but paper's not a hydroxide. So, this is just what we're doing this unit, and that's it. Thank you.